Okay, Bismillah, let us do more questions relating to definite integral, okay, with an absolute value. So let us do question number 17, 18, 19, and 20 taken from your workbook, page 210. Okay, let's do it together. So we know that absolute is actually a symbol, so you cannot integrate straight away unless you define the absolute value symbol. Okay, get the absolute values. So in order to define this absolute, we need to understand the function. So this is actually the graph of our cosine, okay, from 0 to 2 pi, and we are to extend on the left until 3 on 4 pi. Okay, so we need to understand the function before we can be able to define the absolute. Absolute meaning you cannot read the y as a negative. So whenever we have a y value being negative, we need to flip. Okay, so for this portion from negative 3 on 4 pi to negative pi on 4, 5 on 2, sorry, we read it as a negative value, meaning we flip this graph. And then from negative pi on 2 to pi, okay, we can read as is, the cosine. As for the pi on 2 until our upper boundary is 3 on 4 pi, so again we need to flip, meaning introduce the negative. So you have to define this absolute first. Okay, and then only you are to integrate cosine. Looking into your formula list, the integral of the cosine is in sine. Okay, so we read sine. Over here I put this negative outside, so integrating cosine we get sine. So we then, after we have integrated, we need to substitute the boundaries, upper boundary minus the lower boundary. Okay, upper boundary minus the lower boundary, this one. Be very careful with the plus and minus. Again, here I put the negative up front. And here we have a negative angle. You should maybe use even odd property such that whenever you have a sign of a negative angle, you can read it as a positive angle. So sine negative theta is negative sine theta. So I'm playing with an even odd here. So it's a negative pi on 2, so that is easy for me to read later on. So this is negative plus. Okay, so this is negative again, negative plus. So here I'm expanding the negative inside. So that, right? So do simplify your work before you read the values accordingly. So like this one, let's expand this negative further inside. So if we simplify, we can see we have 1, 2, 3, 4 of sine pi on 2. Sine pi on 2 is easy. Sine 90 is actually 1. And here we have 1, 2 of sine 3 on 4 pi. Do consider to use the property reading a big angle. So it's similar to a reference angle of pi on 4. Okay, pi on 4, so then it's easy for us, 4 minus 40, if you have to give in terms of the exact value. So you started with definitions of your absolute symbol. Alright, that's how you should do it. Define your absolute symbol before you integrate and before you insert the upper boundaries and to the lower boundaries. Right, let's compare now question 18. I have sketched the graph for you. So to define this absolute of this function, we need to be able to know the graph. So we can recall back on how to sketch by transformation. Okay, starting with the cosine graph and then negative, we flip. So from this curving, now it becomes this curve. Okay, we flip, and then plus half, meaning we shift up the symmetrical line. This is a symmetrical line. From y0 now become y half, this one. And what are the zeros? We just set your function to become 0, you'll get the answer being pi on 3 and 5 pi on 3. So this is the graph and this is the zeros. Okay, you can find the angle there. Okay, from 0. Right, so you have to know how to sketch the graph first before we define it. So let us define this. You can see that from 0 to pi on 2, this is the graph. Okay, so we need to flip this negative portion of our integration from 0 to pi on 3. So meaning for the function we flip, meaning it will carry negative. Okay, so we put the negative there, 2x. As for, and then we continue from pi on 3 to pi on 2, this is positive, so we can just read the function as is. So the definition must be correct. Okay, so we are defining the absolute symbol. Right. Okay. So after you have defined the absolute values like this, then only you can integrate term by term. Right, so let's do it. Integrating negative half is half x. Here we have negative, negative, positive. Integrating cosine is sine. And we are to read the boundary from 0 to pi on 3. Okay, for this function. And then plus. And then we do the same thing. Integrating half, we get half x. Over here there's a negative, right? Be careful with the negative. Okay. Integrating cosine is sine, so negative sine. For a boundary, pi on 3 to pi on 2. So if my calculation is correct, we should get this as the exact value number, or you can just leave your answer as decimal places. Okay. So how much mark will this type of a question carry? Starting with the definitions of your absolute, definitely. And then you are to integrate the function. And then you are to replace the boundaries. And then you are to read the exact value numbers and simplify to the most simplified form. So this question can carry a nice 5 marks. Alright, now let's concentrate on question 19 and 20. Why don't you try them first? Okay, before you are to integrate, make sure that you define the absolute symbol. So find first the absolute values. So here I'm helping you with the picture or the graph for 4 minus x graph for question 19. This is how it looks like. And since that we are to integrate, integrating meaning you are supposed to get the area from negative 1 to 3. Okay, so this portion you need to flip because you have to read it as an absolute value. And then for 20 as well, this is the definition. So why don't you pause and try 19 and 20. I'll give you 5 minutes. Alright, let us compare work. For question number 19, this is how you are to define your absolute value. Okay. For 2 to 3, from 2 to 3, we need to read it as a negative. Right? It must be correct first. Then we integrate accordingly. And then we substitute the upper boundary minus the lower boundary. Likewise, upper boundary minus the lower boundary. You can use straight away your calculator, or here I'm simplifying them first. And if my calculation is correct, we should get 11, 1 on 3 for our final say on the answer. Okay. And then number 20, let's compare work. So the definitions of absolute. So for the boundary from -1 until 0, the absolute x there will receive negative, and then we continue with the boundary from 0 until 2, okay, the upper boundary. So greater than 0, the absolute x will receive positive. So this one must be correct. Up to this level, how to integrate? You know that there is no power rule for the integration. So you do need to know how to integrate. In here, we are to use this technique of integration, the U substitution. So how to integrate? Let's use U substitution. Like this one. Okay, we need to replace everything in terms of U. This is how the boundaries of the x. I want to change it into the boundary of the U, such that the U is 3 minus x. So when x is 0, the U is 3. When x is -1, okay, the U is 4. So accordingly, we need to change everything in terms of U, okay, and the boundary as well, and then we integrate, and then that we read the definite integral for it. So as we are to integrate for this term, we get to this, and then we do the same thing. To integrate this, we need to use a U substitution. Substitute the boundary as well. Everything in terms of the boundary of U, so we get this. Right, so next, to get to this, let's combine it. Okay, let's mention, put it down here. So hence, our integration will become this thing, -2 square root 3 plus 16 on 3. So we need to add plus this thing, okay, 2 on 3 of square root of 5 power 3 and minus, okay, let's open up. So 2 on 3 of this thing, 3 cube, which we can actually simplify, become like this. Okay, so for this portion, the 3 cancel out. So this one will become eventually 2 on 3. The radical of 3 power 3 is 3 square root 3. So this is cut. You get 2 square root 3. 2 square root 3 here, minus. So we have minus 2 of 2 square root 3, which is 4 of square root 3. And then we have 16 on 3, and we have 5 power 3, which you can simplify. 5 power 3 is what? 5 power 3 is actually 5 times 5 times 5. So it's similar to 5 square root 5. Okay, 5 power 3 is actually 5 square root 5. So 5 times 2, let's simplify this. So 5 times 2 is 10 on 3. Okay, so we have 10 over 3 of square root 5. Okay, so check to my calculation. I think this should be it for our exact value number. You can leave as decimal, or you can leave as a exact value numbers like this. Alright, so do more. Okay.